Go ahead.
It's for, I think it was trig 3.
Trig 3. Trig 3. Which one?
Do you think you can go over number over number 5?
Okay. Number 5. Okay. Number 5 says the following. Okay. So what we have here is a triangle, right? It's a triangle. It works in a right triangle. I typically would like to do the following. Okay. Suppose we're in the first quadrant. Suppose we're in the first quadrant.
Okay.
We have a triangle. This is right triangle. Okay. So what I'm going to do is I'm going to label the 3 sides: A, B, C. Right? A, B, C. So this is the right triangle. This is a right triangle. All right. So now, suppose this is X. And what would this be? What will be the B? What will be the B angle? Is it going to be pi over 2 minus X, right? Or theta? Okay, we use a symbol to theta in the question, so I'm going to use theta. Right? Theta. So what will be this angle? This angle is a complement. Pi over 2 minus theta. Right? Pi over 2 minus theta. So what you can do is that, oh, did I erase that C by accident? But it's not a big deal, okay? C is not a big deal. So I deleted by accident, so let's put it back there. It's not a big deal, okay? So what I would do, I will, the opposite side to the B angle, I'm going to call it B. The opposite side of C angle, I'm going to call it C. The opposite of A angle, I'm going to call it A. Okay, so let's look at the following derived. Okay, the definition of cosine of pi over 2 minus theta, right, is equals to what? Basically, cosine pi over 2 minus this angle, right? Cosine of this angle is the adjacent sides over C, right?
Yeah.
So that's going to be A over C. Right?
Okay.
So what is sine of theta? Sine of theta is also A over C, right? Yes?
Yes.
Because the opposite over hypotenuse, right? So therefore, cosine pi over 2 minus theta is equals to sine theta. So that's number 5.
Wait. So the question is the answer?
Yeah, this demonstrate number 5 is right.
Oh, we have to prove it right.
By definition, right?
Oh, I did this the wrong way then. I did
Maybe
this,
just a little bit, right.
I
So what
did
did
this,
you do?
I did this like a whole different way. I did
But
this.
this is not the only way to do it, Jacob, though.
What I
As
basically,
we progress, there are other ways to do it.
yeah, what I basically did is I picked like a random point on the unit circle closely related to cosine and sine. Basically, I picked for theta pi over 6, right? And then I put that in. I basically subtracted pi over 2 minus pi over 6, right? And then for cosine, I got pi over 3, which equals the sine of theta, which equals the sine of pi over 6. And then I did like cosine of A times cosine of B plus sine of A times sine of B. And then I just kind of like had to like do a little guessing game and see which one would equal which to see if it would equal itself.
You can do that way too.
Okay.
But you cannot use pi over 6.
Yeah.
Okay. If you do that way, okay, if you do that way, it will be fine. Okay. So let me show you. I think what you can do is that you can do cosine pi over 2 minus theta, right? You said you use cosine pi over 2, right? Pi over 2 multiply cosine theta, right?
Yeah.
Plus, is that what you did?
Yeah.
That's okay too. You should get it too. And this is sine theta. Okay? Cosine pi over 2 is 0, so this whole thing is 0. Sine pi over 2 is 1, so you're going to have sine theta. So you're going to have sine theta. So what you did is right too. But what I did here is provided that you don't have any complication. I mentioned earlier is in the first quadrant, right? What happened in the second quadrant? You had to bring the reference angle in. All right. So this way is probably the easiest way to do it. If you want to explore the other way, like what I did here, you have to do in every quadrant. But you'll get there. You get there. You just have to introduce reference angle. So this way you did. It's the easiest way to do it, but provided that you know this formula. So you're good. You didn't miss anything right here, right?
No, I think that's what I put down.
Yeah, that's correct. This way is something I like to do for remembering the formula. Okay? Because when I was a student, I remember this formula seemed to be a little less intuitive for me for some time. So I have a hard time with it. So later on, I realized if I use this triangle thing, it will help me to get it right. So this way could be your reference, right? To convert, to express sine to cosine, cosine by sine. Do you understand what I meant here?
Yeah.
Yeah. Any other questions?
Do you think you can do number 6?
Sure. Number 6 will be similar, right? If you're into deriving, so I'm going to clean this up, right? If you're into deriving like what we did, so this is number 5, trig 3A, number 6. if you're into deriving, what you can do tangent. Which way do you prefer? Did you do the deriving way?
I got kind of stuck on this one. Like what I did is I did tangent of x minus tangent of y all over 1 plus tangent of x and tangent of y, but I think that's wrong, is it?
Oh, what formula? What there's some formula here, but if we use the most basic, right? There are specific formula for tangent. I don't think you the formula you use doesn't sound right. Can you say it again? Maybe I missed something.
I did tangent of x minus tangent of y all over 1 plus tangent of x times tangent of y.
Oh, that's okay. That should work. But we have a problem here. Because you have tangent pi over 2. Tangent pi over 2 is undefined.
Oh, that's why it didn't work.
That's why it didn't work, but it could work this way.
Okay, I did the wrong way then, I'm guessing.
Right, you see that domain it gets you in trouble.
Okay, I
Okay,
see.
so what you do, you can do this. Okay, if you're into the deriving, right? So what you can do is this, right? So on the top, you have sine pi over 2. Cosine theta, right? Minus cosine pi over 2. You know these basic formula, right?
Yeah, but it's been a while since I'm like a little rusty on those ones. It's been a while.
But it's okay. But since you did the deriving, so I'll just follow that idea. Okay, but you can also do the way I did first for number 5, the trick, the geometry way. Okay, and on this part you already did it, right? We're on the cosine pi over 2 over theta, we just copy and paste here, right? We just copy and paste here. Yes. And then I will show you the other way. And then what you get is that you're going to simplify this piece, right? You're going to simplify that piece. Well, that's a 1. And that's a 0, right?
Do you think you can slow down a little bit? I'm also writing this down as well.
Sine pi over 2 is 1. So the formula I use here is this, okay? You already know the formula for cosine, right? So for sine, a plus b, well, this is a minus b, is equals to sine a cosine b. We're going to talk about deriving these formula later, okay? Cosine a, sine b. All right. You see that?
This is for sine, right?
That's for sine a minus b.
Okay, give me a second while I write this down.
I will show you the other way, the geometry way to do it.
Okay, I'm ready.
Okay, so sine pi over 2 is 1. Cosine pi over 2 is 0, right? Cosine pi over 2 is 0. Sine pi over 2 is what? Is 1. Right? So we just organize, I'm copy and paste this line, just organize. Right? So this piece disappeared. Right? 1 times cosine theta is a cosine theta. This piece disappeared, right? So this piece is, we don't need a positive sign. 1 times sine theta is that. So that's going to be cotangent theta. Right? So that's the whole proof. If you're into that formula deriving piece, provided that you know the formula, you know the formula. Okay. We will talk about these formula another time. But if you look at the geometry perspective, right? The geometry perspective, which is similar to what I did on the other one, right? And this is how it works. From geometry's perspective, this is good for memorization, okay? The geometry perspective, all right? So suppose I'm drawing this triangle. Once again, it's a right triangle. Okay, so this angle is A, and this angle is B, and this piece is C. And B across from B side, and A cross from A side, C comes from C side. Okay, so this time I think I would write it more, write it better, is that we want to demonstrate. So if you have a theta, suppose I have theta here. And this angle, what would be this other angle? This angle B is going to be pi over 2 minus theta, right? Right?
Yeah.
Because these two are complementary. This is right triangle, right? This is right triangle. Now, what I would write next is that what is a tangent pi over 2 minus theta? This is the angle pi over 2 minus theta, right? So tangent of it will be the opposite over over adjacent. So this is going to be equals to B over A. Right?
Yeah.
But what is a cotangent theta? Cotangent theta, this is theta. The adjacent side for theta is B. The opposite side for theta is A. So that's going to be B over A as well.
Which then checks itself out. Therefore, it's good.
Right? So therefore, tangent pi over 2 minus theta is the same as a cotangent theta.
Okay,
So I'm sorry?
No, is it like when I was doing the homework, right?
Mm-hmm.
Like the question itself, did it make sense? For some reason, it didn't make sense to my head. Because like the way it was asking was like really weird. Give me a second. Let me pull it up and like say what it was asking. Cause like the way it was worded was like really weird too.
Where? Which one?
For Trig 3, and the way it was just worded didn't really make any sense, to be honest.
For Trig 3A?
Yeah, it said like derive the following identities.
Right.
So it basically just means like check the question itself, right?
You basically take you from left to right, right to left. Right? That's what identities are. Right? Left is the same as right, right. So you can either take from right to left or left to right.
I see.
And everyone, there's more than one way to do it.
Yeah.
Right? There's more than one way to do it. So the purpose of these exercises basically to get you, they are the pretty basics identities. You see more complicated identities at Trig 17 and Trig 18. So I want you guys to get started on these simple ones. and they're very useful.
Yeah, I actually tried doing 17, trig 17, but didn't get far, to be honest.
No problem. Let's try some. Trig 17 you meant, right?
Yeah, I did like only like 3 problems because it wasn't like making any sense to my head, I think. Because I did number 3, I did tangent of 15 degrees.
Trig 17?
Mm-hmm.
Trig 17, this is basically, you need to use those, you know, angles of some half angles, right? Because 15 degree is half of 30 degree.
Yeah.
So you use half angle formula.
Okay. Do you think you can do you think okay? I got an answer for number 3, but I don't know if it's the correct answer though. Can you check me?
Sure.
Okay, for number 3, I got negative radical 3 plus 2.
For number what? Number 1?
No, for number 3.
Number 3. So this is a trig 17A, right? So we have a sine 5 degrees. So which formula did you use? You should not be using calculator though.
Yeah, I know. What I did is I simply just kind of converted it back and forth a little bit, I think, is what I did, which got it all crazy like.
This is to train you guys reflective on the formula of trig formula, because this will just give you, this is going to be just equals to sine of 5 degree plus 40 degree. This formula, the formula I just gave you when we were proving tangent. This one.
Okay.
Okay. But this one is this is a plus, right?
Mm-hmm.
If this is plus minus, this will be plus minus. So in the end, this equals to what? Sine of 45 degrees. So it equals the square root of 2 over 2. Is that what you got?
For which number?
Number 3.
No, I did not. Okay, I did something wrong then.
So you saw what I did here, right? So these exercise for trig 17A is basically about the form, because you see where these exercises are located, right? Is right behind the formula sheet. You see on page, because right before that page is a formula sheet. I made a diagram of all these trig formula that might be of use to you. And most of them will be very useful to you. I made this chart. We're kind of a little ahead of our time. But for those of you who had a trigonometry, these are not strange to you. You guys see that formula sheet?
Yeah, I see it.
Yeah, so you guys, these exercises will get you guys familiar with the formula sheet, which you already had in trigonometry. But I will have planned to derive them with you guys. Okay, in the past, there's a recording in the past, and I put it on the module. I'm going to show you where it is, so that way you can have a head start. You want me to show you that to you?
Wait, give me one quick second. Like, give me a minute. Sorry.
No problem, no problem.
It's because like I felt like I did this before, but like I just forgot because of summer and COVID.
Oh, no problem, because this class is a review. I just try to give you guys as much resources as possible. So did you try to write down what's in here? Did you write that down? Is that what you're trying to do?
Yeah, I'm gonna get done right now, and I'm almost done,
No problem. Just take your time.
and I'm done.
Okay. So regarding the formula in front of this piece, right? You saw that formula sheet, right?
Yeah, right here, sine of A plus B is equal to sine A cosine B plus cosine of A times sine of B, right?
Right. But
Yeah.
I had a plan. Okay. Which I did, I did many times with my classes before. So I have the recording. Okay. Do you see the module?
Give me one quick second.
Module.
Open the mod. Okay, I'm looking at, is it week 5?
No, it's not week 5. It's a trig review.
Oh, true.
Right beneath homework.
I see. Okay.
Okay, derive trig formula, part 1,
Oh,
part 2, part 3, part 4.
I see.
These are the past recordings. Okay, we haven't get a chance to do it in this class, but you can watch those past recordings and show you how these formulas have been derived.
We're gonna go over these formulas like tomorrow on Monday, right?
We try. Okay, but if that's sure, we can do that. Yeah.
Thank you so much.
Of course.
And again, sorry for taking your time again.
Oh no worries. I'm delighted to answer your questions. Okay, anytime.
Okay. Yeah, that's all the questions I really have. Now I understand what I need to do. I'm probably gonna go back to my homework and redo them a little bit now that I have the knowledge of this now.
Good.
Because the way I did it was really wacky. Give me a second. I think my
All right, guys. Do you guys have any more questions?